So good morning, good afternoon, good evening, wherever you are in the world. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through unforeseen circumstances due to COVID-19, we wish everyone and their families a safe time. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference. The papers will be published in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times. We make this conference more fruitful in terms of technical knowledge and hope you enjoy the 2 days of the knowledgeful and interactive sessions. I would like to welcome you to the technical session number 6C and further introduce you to the chair session. If we could briefly get the slide changed. So the chair for today is Dr. Anita Sharma, who I am going to briefly tell you a bit about. I hope I don't get anything too wrong. So Dr. Anita Sharma is a senior assistant professor and research supervisor at IISc University. She's an experienced teacher with a demonstrated history of working in the higher education industry for more than 14 years. She is a strong education professor with a master's degree focused in computer science from Banasveli Vidyapith and PhD in software engineering. Probably said that wrong. From JNR, from JNR Rajasthan Vidyapith Adipur. She has supervised more than 5 PhDs in student projects in domains like data mining, machine learning, cryptography, software engineering. She has published more than 40 research papers, international journals and conferences. She has reviewed various DST projects, international journals and conferences articles. Currently, she is a reviewer of a renowned publication, IEE Transaction on Neural Network. Dr. Amita Sharma is also IITB Remote Center Coordinator for Outreach Programs and Coordinator of MBA Business Analytics at IIS University, and has coordinated a large number of IIT Bombay workshops at IIS Remote Center. Dr. Amita Sharma is an active member of CSI and BioClues. She has received Best Performer Award in MHRD Approved Refresher course on computer application organized by Kotta University in 2016. So Dr. Amita is definitely prepared for the role. So we will now start with our first presenter, which should be Bushra, presenting prediction of movie success using Twitter temporal mining. So Bushra, when you're ready, please connect your...
you.
Yeah, oh, there you are.
Good afternoon.
Good afternoon.
Let me share with you my presentation first. Okay, I think I am not able to share a proportion of the screen.
What you need to do is if you look at the bottom of your screen, there should be like a green icon that says share screen. Then if you click that, and then just click whatever screen you are wanting to show.
Okay.
Right, it's just, yep, there you go, all good. So whenever you're ready, good.
That's much better, yes?
Yep, we can see it all now.
Okay.
So whenever you're ready.
Good evening. Me, Bushra Hijawi. I will present it to you today, our contribution prediction of movie success using Twitter temporal analysis. Let's start with a quick introduction to discuss the problem and challenges. Social media such as Facebook and Twitter are powerful platforms where people can share their opinions about products and services. Public opinion has a critical impact on businesses and may have effect in their future decision. Those businesses analyze the users' opinions and feedbacks on social network to enhance their services and meeting their customers' needs. Twitter's with over 300 million monthly active users cover a wide variety of people, thoughts, and topics, making it a gold mine for companies to enhance their future decision. For example, users with the Twitter real-time sharing feature, they can share their opinions about movies while they're watching them. You know what? The movie industry is a big business that carry profits and loses up to millions. Every year, thousands of movies are produced in various languages, genres, with cast from different countries. Movies are a great source of entertainment for people and may affect their decisions, lifestyle, and political opinions also. Various websites keep tracking the movies and track their success, such as Rotten Tomatoes and Internet Movie Database. Those websites track movies from different perspectives, such as rating, revenue, and popularity. Usually, researchers in this research area focus on studying the movie success from cumulative perspective. For example, from the overall satisfaction of users, view-based popularity, and the total revenue of movies. However, in many real scenarios, we need to analyze the temporal movie success. For example, every year between November and January, Christmas movies are on the top 100 popular movies list of IMDb. As you can see in this example, the movies also doesn't mean that if the users like the movie, then it will be in this popular list of items, as you can see in this example. Here. Those we aim targeting customers with products that meet their. Give me 1 minute, please. I'm sorry. That meet their interest within a specific period of time, providing businesses with the recommendations of the near future popular movies will help them in attracting more customers. I'm sorry for the interruption, but I'm a COVID-19 patient. Okay. The core idea is focusing on predicting movie success by analyzing tweets and predict their success from two perspectives. Satisfaction level, which refers to the average ratings of users, and the temporal popularity, which is a binary measure indicating that a movie is a trend within a specific period of time. To the best of our knowledge, This is the first work in this research area that tried to predict the temporal popularity of a movie by analyzing tweets. To summarize, our goal: benefit from the textual feedback on Twitter to predict average satisfaction of users and temporal popularity of the movies. To achieve this goal, we need those requirements. We need the top 100 popular movies on Internet Movie Database, which is weekly updated, the average rating of users with a particular movie, and a movie-related tweets. Unfortunately, we try to find such datasets to study the relation between tweets and the popularity of movies within a specific period of time, but we didn't find those. We collect a new dataset. Our dataset, so our model is consist of 3 phases. The first phase is data collection and processing. Our dataset is called Tweet a Movie. Tweet a Movie is a new movie rating and temporal popularity dataset which has been collected from IMDb and Twitter. Tweet a Movie stores regular features about movies such as rating, genres, release year, for example, and tweet-related features such as the tweets themselves, number of likes, number of favorites on that tweets, number of replays, posting time, and popularity features, which is collected from IMDb. We have 2 types of tweets in our dataset: structured tweets and unstructured tweets. We extract structured tweets by using regular expression, which is start with I rated and finished with the hashtag IMDb. While the unstructured tweets, we querying the movie title and analyze the tweets that we got. However, we face a challenge while extracting unstructured tweets. When the movie title consists of words that may be used in different contexts. For example, for the movie They Live, we got the following tweets which is unrelated to movies. To handle this issue, we use the IPM Western Natural Language Understanding Service to analyze their categories and include only movie-related tweets in our dataset. Phase 2 is responsible of analyzing the sentiment of tweets, emotions, and feature generation and feature selection to prepare them for training and testing our model. In order to analyze the sentiment and emotions in tweets, we use the same service that's provided by IBM. However, this service was not able to analyze the sentiments in the structured tweets since they remove the rating number in the pre-processing step. To handle this issue, we suggest the following predefined rules to analyze their sentiment and emotion based on the rating in the structured tweet. The next step is to generate and prepare features for the models. The rating prediction model uses the cumulative tweet-related features. For example, we use the overall count of tweets for a particular movie or retweets on a particular movie, while the popularity prediction model is use the temporal feature. We only consider the count of tweets within a specific period of times to predict the popularity within that week. The third step is to build our model. The rating prediction model is an ensemble regression model, consists of 6 regressors, as you can see in this overview. While the popularity prediction model is a random forest, consists of 50 decision trees and predict the popularity of the movies.
Sorry to interrupt, you've just got 2 minutes left.
Okay. In our experiments, we use 3 measures, mean squared error, mean absolute error, and R-square. As you can see in the table, the rating prediction model is outperform other techniques. In order to evaluate the popularity prediction model, we use accuracy, precision, recall, and F1 measure. Also, our random forest show a great performance in terms of accuracy, precision, F-score. However, other methods outperform it in recall, but we can see here that the precision is much higher than others. So other methods maybe, or let's say they have a high false positive rate. To summarize, this research presents 2 new movie success prediction models, rating prediction and temporal popularity prediction model. In order to evaluate our model, a new dataset has been collected called Tweet a Movie. Tweet a Movie consists of 3 types of features: regular features, temporal features, and tweet-related features. The proposed model can be integrated with other systems such as information retrieval system, and recommender system to improve their performance, which is our next step. And thank you.
Right, thank you very much for that. To the chair, Amita, do you have any questions? Or if anyone else has questions, just put them in the chat box.
Can I ask a question?
Yeah.
Yes, please.
Yes, I have a question. It was very good presentation. Just what was your data size in this whole experiment?
Okay, we have more than 1,400 tweets.
Okay, and after filtering, how much was this data size?
Those after filtering. Before
Okay.
filtering is almost 500,000.
And what
Yes.
was the training set and testing set? Did you divided them?
Okay, yes, I can show you something here. We have 3 experimental setup. Div 1 consider only 30% of the data set, while Div 5 and 10 consider the k-fold cross-validation.
And what about the balance? Did you check the data set whether it is balanced or unbalanced?
No, it is unbalanced, and we use oversampling technique.
Okay, you use oversampling. Okay, thank you
Yes.
so much.
Thank you.
Right, thank you for that, Bushra. Up next, we have Lewis Ellis, who will be presenting an alternative auction system to generalized second price for real-time bidding, optimized using genetic algorithms.
All right. I share my screen here.
Yeah, that's fine. Yeah, we can see it now. Good luck.
Yeah. All right. So I think I'm gonna leave it like that. Okay. So in this paper is called an alternative auction system to generalize second price model for real-time bidding. So this research has been carried by Luis Miralles, myself, for Fernando Jimenez and Jose Manuel Garcia from the University of Murcia, and me myself, I am at TU Dublin University in Ireland. So the situation we have here is a real-time bidding, which is a very popular advertising system, and it works for the exchange of adverts online. So on the one hand, we have the advertisers, which are which pretend to publish their adverts on the publishers' slots. And on the other hand, the publishers want to get as much money as possible for their adverts. So the system that is currently used is the generalized second price. And in this model, the advert that offers the highest bid gets the slot and is charged with the price of the second highest bet or bid. So what we think is that this system prioritizes too much the short term. It only cares about the short term economics, and it is in the long term there are factors that can make that this system doesn't work that well. So what we did is we proposed a novel advertising exchange system between advertising networks. So imagine that you have different advertising networks. Here is one, another one. Each advertising network is composed of advertisers and publishers. And the thing is that if they exchange adverts, they all win. For example, if there is an advertising network in Japan and there is another one in Brazil, okay, if I am based in Brazil and I get visitors from Japan, I'm not going to be able to show them adverts. So it's a better idea to do some kind of collaboration with the Japanese and people that access from Japan to my website. I can leave those adverts for my Japanese network and the other way around. So exchange is better for all of us. And in this model we are proposing, we are focused not only in the economic aspects, but we are also considering other factors like advertising impressions percentage, spam advertisers, campaign profitability, fraud, and satisfaction of the different roles that compose the advertising exchange system. So in order to do that, we created this module. The module is created by using is composed of other modules. One is the CTR estimation, which is the probability that a user clicks on a given advert. We created a fraud detection advert to estimate the probability that an advert is a fraud, is a spam. And we also create another module called database, which gather some information about the system, which is going to allow us to estimate, define some metrics to represent the satisfaction of the different roles. So with all those three modules, the advertising selector will select the best advert based on a formula that we define. So the formula that we define goes as follows. We, if you want to get into the nitty-gritty of the paper, you can read the paper. But basically, we created a variable to represent the satisfaction of the advertising networks based on the number of adverts that it gives and receives. We created another variable called advertiser satisfaction, which basically is up as long as advertisers are able to publish their adverts. We also created a metric, and this metric will go down if the spam adverts are very high. Campaign cost is to avoid publishers from overpaying from their adverts. We don't want to take advantage of them, so they think that our network is very expensive, but they don't come back. So we're looking forward for the long-term benefit. Again, publishers can also make fraud, and we are going to estimate that. And the ad value is simply the value of the advert. So is the price that the advertiser is willing to pay for his advert or head advert to be published. So with all that, we create a function, and we estimate a value. And we also have weights. The weights, there are 6 weights, and they all of them add up to 1. And those weights are associated with each variable. And we're going to optimize the weights using a fitness function. So we're going to estimate how good those weights are by adding up the price of all the collected clicks minus penalization that we're going to define when objectives are not met. All right, so we defined the economic penalties. For example, we say that for each advertiser whose impressions lies below 25%, we will penalize the system. If the advert has too much spam advertiser, it will be penalized. And campaign profitability, if users advertisers overpay, they will also be penalized. And also for the other 2 variables, which are the balance in the networks and the fraud in the publishers. So to optimize the system, we use a well-known technique called genetic algorithms, and the genetic algorithms create different individuals. The different individuals are going to be converted into different weights. We're going to evaluate the weights. We will select the best individuals, and we remove the worst ones, and we'll make different iterations in order to optimize those weights. So the algorithm goes as follows. For all the visits, we are going to evaluate all the advertisers that are in the same category as the advert. For each of them, we will calculate this value with the formula that we already explained, and we will select the advertiser with the highest ad value. Then we will apply, we will update you remember that there was a module for the database, so we're going to update that module. We're only going to update it every 1,000 visits, because if we did so every visit, this algorithm will be too slow. So we do it only every 1,000 times. And then we calculate the fitness associated with the 6 weights, so we can score or rank the different individuals. So we conducted 2 experiments. In the first experiment, we compared the 10 networks working independently and 10 networks working in a collaborative system. We saw that when they collaborate, the performance is much better because no adverts go wasted. So it's a win-win. And then we compare the traditional generalized second price payment model with our model based on a genetic algorithm system. And we see here that because the generalized second price doesn't try to optimize the penalizations, it gets a lot of penalizations. So our model, according to our metrics, works better. So to conclude, we provide here a very interesting point for creating new payment models that are based not only on the economic aspects in the short term, but also considering important factors for the functioning of the network. One of the drawbacks of our implementation is the fact that it's a bit complicated to understand, so advertisers prefer models more transparent. that will be one of the drawbacks. But anyways, our methodology is still valid, and we consider it's a good value and an interesting approach. So we created that CPR and if the CPR and fraud detection models were improved, our methodology would work better. And as future research, we are planning to apply this model to other payment models, not only pay per click, but also pay per impression or pay per acquisition. So that was it. I hope you liked it, and thank you very much for listening. I'll be very happy if you have any question.
Thank you, Lewis. Yeah, if anyone has any questions, please just write them in the chat box. If not, I'll just hand over to Amita, who.
Yes, I have a question. Yes, it was very good presentation. Very clearly explained each and every part, especially the objective function. But I have a small question, a quick question. What is the mutation policy adopted for genetic algorithm?
Well, to be honest, you got me there. I had to look at the paper, but we were more focused on explaining the general like methodology and the pipeline rather than into that. But I can post it there in the chat as soon as I find it. I think that I want to make people wait.
It is very good if you can experiment with different mutation policies. Definitely, the performance of the model will improve.
Yeah.
You can try that way also.
We tried a few of them. I think that we tried 0.1 to 1. So we created a matrix and then we selected from those 100 combinations. I think that they are the optimal two. So that's what we did. Yeah.
Okay. Thank you so much.
Thank you.
All right, thank you, Lewis. Up next, we have Fuzzy Reinforcement Learning, Multi-Agent System for Comfort and Energy Management in Buildings by Anagiotis. Sorry if I pronounced that wrong. Oh, there you are.
Hello.
Hello.
Hello, dear Liam. Hello, everyone. Nice to meet you. So should I share my screen?
Yeah, go for it. Whenever you're ready. Good luck.
Yeah, so where's the screen? Basic. Not whiteboard. Let me find it, please.
Yeah, fine.
I have a file. So, slide. No. Files. So could I have some help? I mean, where?
Yeah, have you got the file open already? What you want to present in PowerPoint?
Yes, I mean I have a file.
Yeah, but if you have you got it open?
Yeah. It's yes, it's a PDF file.
Yeah. Okay. If you click at the bottom of the screen, there should be a green icon that says Share Screen.
Yes, I know, but there's no such.
Well, you can't see it. Okay. Perhaps if you in the bottom right corner, it should say Show All Windows, and then it should hopefully offer you the option to show.
Share sound. Just wait a sec. It's a whiteboard. Slides as virtual background. Let me share this. No files. Dropbox, OneDrive box, Microsoft SharePoint. So does this platform works only with Windows? I mean,
not as far as I'm aware. Oh, Anthony has said, make sure you select basic tab after share screen button.
Yes, it only gives me the whiteboard.
Is there not an option? Does it not say like, oh, mine isn't cut now because I've already pressed it. I know what you mean where it says whiteboard. Is it not showing any of your other?
No, unfortunately not.
Right. Okay.
So advanced, I mean, I'm on basic.
Yeah, that's what I'm looking at now. I'm looking at advanced and files.
Oh, okay. So I think I got it.
Okay, that's fine. Take your time.
So
I can see it now.
okay. So hello again. I'm so sorry for the any convention. So yes, I am Panagiotis Korkidis. I will talk about our work on fuzzy reinforcement learning multi-agent system for comfort and energy management in buildings. Okay, so this work is in collaboration with Dr. Panagiotis Kofinas and Dr. Anastasios Dounis and myself from the Department of Biomedical Engineering in University of West Attica, Athens, Greece. So energy management, as is obvious, is really critical in modern societies as far as environmental and financial aspects are concerned. So, and then maintenance of the indoor environment in good levels under an energy efficient framework of force is a crucial task. So in this work, we propose a multi-agent system, MAS, to maintain the comfort in an office building in high levels and reducing the overall energy consumption of the control systems. So we deploy 3 independent agents dedicated to one comfort factor. Each agent is dedicated to one comfort factor. There are 3 comfort factors: the thermal comfort, the visual comfort, and the air quality. So we combine fuzzy theory and Q-learning to deal with the continuous state action space. And we show some simulation results that prove the superiority of the proposed system with respect to an on-off controller. So the contributions of our paper is that we develop a fully decentralized multi-agent system. The control framework is robust since the agents act independently. Q-learning is implemented in each agent to adapt its behavior in the environmental changes. The fuzzy approximation is considered in each agent to deal with the continuous state space action. And both indoor comfort and energy consumption are embedded in the reward signal for both achieving high comfort and energy consumption. So let's talk about buildings comfort. There are 3 major factors affecting the overall comfort in a building. It's the thermal comfort, which is basically the temperature of the indoor environment. It's the indoor quality. It's the concentration of the CO2. Okay, and the visual comfort, it's the illumination level. So in our model, we use the heating cooling system, the ventilation system, and the artificial lighting system as actuators in the control framework. Okay, so you can consider this as a block diagram where we have in the classical automatic control framework, we have the model, okay, which is the building, which has 3 outputs. Every output is a particular index, okay, and we try to control these three indexes by using the heating cooling system for the thermal comfort, the ventilation system for the indoor quality, and the artificial lighting for the visual comfort. Okay. Okay, the first part of our paper is considered with the Q learning. Okay, Q as quality. The letter Q is from quality. So it's a type of reinforcement learning algorithm where the agent gradually builds a Q function, this quality function. Okay. Where the Q function estimates the future reward actions in given states. Okay, so the governing equation, as it's already know, it's nothing new. It's this equation right here. Okay, so we have, let me explain some things on this equation. So Q dust with arguments X and A. X stands for the states, A is for the actions that the controller must take. Okay, so the update, it involves the update of the old Q function plus some, let me say, correction terms. It's weighted by a learning rate, which is G. Okay, and we have this R is the reward function plus some estimate of the optimal future value, which is this gamma times max with respect to A, minus the old value of the current Q function. Okay, so this is the basic Q learning, the basic Q learning methodology. It has two main drawbacks. It's impractical when the state action is very large. Okay, because it builds a matrix. It's a tabular form of reinforcement learning, so it builds a 2x2 matrix. So if the state action is very large, so it's really slow, and it cannot be applied for continuous state action. Okay, so you consider this one as the same because, okay, very large and continuous, it's almost the same. Okay, so what we propose in our paper, I didn't want to make any more mathematical explanations, but I will show it in a block diagram. So this red box is the environment, it's the building. Okay, we have sensor readings for all the thermal indexes and measurements. Okay, so we propose the fuzzy Q learning algorithm, which uses the pros from the fuzzy theory, the function approximation theory, okay, and the pros from the Q learning. Okay, so we have a fuzzifier, fuzzy inference engine, and a fuzzy rule based on the defuzzifier, okay, which interact with the Q learning algorithm, and the output of the defuzzifier is the global action to the environment. The global action will mean the signal to the actuators, okay, that will keep the environment, the building's environment in this desirable levels. Okay, so the building modeling, the multi-agent system, there are three subsystems as already mentioned, is the heating cooling system, the daylighting and artificial lighting system, and the ventilation system. Okay, it's responsible to a particular index. The multi-agent system consists of a group of three agents, A1, A2, and A3, which A1 stands for the temperature agent, A2 is the luminance agent, and A3 is the CO2 agent. Okay. And this is a block diagram of the multi-agent system. Let me explain further. So we say indoor temperature and indoor CO2 concentration as inputs to the, as well as indoor illuminance as inputs to each agent, temperature, illuminance, and CO2. Okay. We have outdoor signals, which stand for output temperature, outdoor illuminance, and outdoor CO2 concentration. The red arrows stand for the consumption, okay, of each system. And each agent sends a signal to the actuator subsystem, which is the artificial lighting, the ventilation, and the heating cooling system. Okay. So the heating cooling system will send as a control signal the air flow rate and the ventilation system as well. And the artificial lighting will use this fluorescent lamps and electrochromic windows to maintain the set points, okay, in the desired levels. Okay, so let me talk to you about our simulations, show you some results. We used 1 year's period with a simulation times of 0.001 hour for our numerical experiments. So the data concerning the outdoor temperature and the diffuse horizontal illuminance of the sky, okay, so is these signals here, okay, on the is acquired from the database of Software Energy Plus for the location Athens. Okay, so is where we resident right now. Okay. The illuminance values are multiplied by a factor of 0.5, but this is just a detail. Okay, and for the outdoor CO2 concentration, a constant value of 400 parts per million is used. Okay. So let me tell you some things on our simulation and our diagrams. Okay, so here we see the on the top plot we see the outer temperature. Okay, we want to control the indoor temperature, of course. Okay, so the set point we can see in the middle plot. Okay, that the set point is if the outdoor temperature is above 29 degrees, so we set the set point of the control system in 27 degrees Celsius, and if the indoor temperature falls under 20 degrees Celsius, then the set point is set to 22. So we achieve this right here. Okay, and we can see the control signal of the multi-agent phasic learning system here. Okay, this is the control signal for the heating cooling system. Okay, we can see here some let me say it, ups and downs, and some chattering phenomenon caused by the exploitation of the reinforcement learning algorithm. Okay, here in this plot we can see, I will show you in 1 day, better in 1 day, 1 day period. So in here we want to control the total indoor illuminance of the office. Okay, we want to keep it in 700 lux. Okay, so our set point is on 700 lux. So we can see here that when the indoor illuminance from outdoor illuminance is large, okay, basically the controller doesn't do anything. Okay, so it keeps the level on 700, but if the indoor illuminance is low, we have an artificial lighting system, a control signal, which drives again the total indoor illuminance in 700 lux on the set point. Okay. And so let me repeat something. This plot corresponds to the temperature agent. This one in the illuminance agent, and the last one, I'm sorry, the last one is the CO2 agent, which we want the CO2 levels to be always below 1,000 parts per million, below 1,000 parts per million. So we simulated.
We've got 2 minutes left.
Yes. Thank you so much. Okay, so we have we assume that we have a kind of step function that that corresponds to the occupants of the number of people, the occupants in the building. Okay, so we see that we have a high control signal. It's the ventilation system, okay, of the ventilation system, okay, which it's high in order to keep the concentrations, the CO2 concentration level under 1,000 parts per minute. Okay, so we achieve this right here. Okay, and the comfort index with on-off control, which is something that I tell you that it must be always close to 1. With an on-off control is this plot, and our approach, the multi-agent system fuzzy Q-learning, is always nearer to 1, which is better. Okay, so for conclusions, multi-agent system as a solution to the distributed problem is deployed, will reduce overall energy consumption. Okay, and we keep high comfort levels. Okay, and further reduction of 3% to the overall energy consumption is observed. Okay, so I would be happy to answer any questions if there are any.
Thank you for that.
Thank you too, and I'm sorry for the.
Oh, it's fine. It's fine.
Okay, I have two observations from your presentation.
Yes.
Your research problem is very interesting. I really like your research problem.
Yes.
One thing is, did you compare the performance of both the algorithm Q-learning with your fuzzy Q-learning algorithm? Did you try to compare something?
Yes, a comparison is the this one here. We compared a on-off controller. Basically, it turns off or turns on. It's a binary kind of controller. So, okay. So it either it switches off a system or it turns off systems. Okay. Yes, we have only so far we have only this comparison: the on-off controller and our proposed multi-agent system. That's one comparison.
Okay, and one more thing. What will be the effect of weather in your case of in your model if weather changes?
I'm sorry, the effect of
weather.
The weather. Okay. Yes, of course. Yes. The effect of weather, it can be seen here. Okay, in this slide. So this is the outdoor temperature. Okay. As far I mean there is a relation, of course, because our set point inside the buildings are I mean, they relate to the outdoor temperature and indoor temperature. Okay, so in our paper we have a simulation for the whole year. Okay, so you can see the differences in the set points in summertime and winter time. Okay, where we have this rapid changes. Okay.
Thank you so much. And one more observation, or if you can take it further for your research, why didn't you consider noise or sound for in a comfort zone?
Yes.
The sound
yes.
is again an important factor.
This is something we want to study in future research, and as well as the occupancy prediction. This one,
Yes.
this here. Okay, we want to make use of stochastic differential equations in order to predict the occupancy level for future control systems.
Thank you so much.
Thank you so much.
Right, yeah, thanks for that. So up next, we have Hector Lopez, who will be presenting a virtual reality system for the simulation of neurodiversity. Are you ready, Hector?
Yes, I am. Thank you.
Cool.
I will share my screen now.
Nice. Yeah, we can see your screen, so start whenever you're ready.
Right. All right, so I'm Hector Lopez Carral, and I'm going to present this paper related to a virtual reality system that we developed for the simulation of neurodiversity. So to start off, speaking of the topic of neurodiversity, we're going to start by defining what exactly is autism spectrum disorder, which is one of the most common types of neurodiversity. So ASD, it's a quite well-known disorder, and it is known for several things, including deficits in social communication, as well as repetitive patterns of behavior. So these are traits that are commonly associated with autistic individuals. However, many of people with ASD also exhibit another kind of experience that is not so well known, and this is sensory hypersensitivity. Sensory hypersensitivity, well, as the name describes, corresponds to a more sensitivity than usual to sensory stimuli. Traditionally, this is associated with audiovisual inputs, but actually it can be of any kind of sensory modality, including as well touch, taste, smell, and even balance, proprioception, and a bunch of other things. The outcomes of this sensory hypersensitivity can be very drastic and affecting several aspects of the individual state, including basically a shutdown or meltdown, and due to these sensory inputs overpowering the individual and making them unable to actually focus on the task that they are trying to carry out, for example. So, well, this is something that is usually not very well known about people with ASD. And to bring it further, here is a statement from an autistic woman from 1994 who said, "The sensory overload caused by bright lights, fluorescent lights, colors, and patterns makes the body react as if being attacked or bombarded, resulting in such physical symptoms as headaches, anxiety, panic attacks, or aggression." So as we can see, simple things that for neurotypical individuals we just ignore, like simply lights or background noises or stuff like this, that for most people do not really represent a problem. Maybe they are slightly annoying, but not really a problem. For people with ASD, actually, they can cause effects as important as panic attacks or even aggression. So while this is an aspect that is usually overlooked, and in order to actually bring awareness of this fact, and there have been some projects already created in order to bring awareness of this fact. They have been created in a few different modalities. I will not go into a lot of detail here, but there are regular videos, kind of like a movie. I will disable the sound, although it is quite important as well to not annoy you with stuff. Well, here's the situation of a girl in a coffee shop, and the noise of the coffee machine actually makes it very hard for her to conduct a normal experience. Also, we have 360 videos, which is kind of the same concept, but in this case, well, simply in 360. In this case, it's a video created by BBC, which was one of our collaborators for this project, in which the user is placed in a meeting situation, a workplace situation. And here we can see how, for example, the bright lights or the patterns on the floor actually are quite distracting. So of course, this is just a visual effect in order to convey the general idea, the concept. And also there have been some interactive experiences, basically video games. Here we have an example that puts us in the place of a child playing in a playground. In this case, we see a lot of visual noise, which tries to showcase how different visual stimuli can actually overpower the visual input of people with ASD. Cool. And simply some quick examples to see what has been done in this topic. And also another important factor that will play an effect is closed loop interaction. So closed loop interaction is interaction that is modulated in real time by certain aspects of the user. So in this case, we can use what is called biofeedback in order to adapt the system based on how the user is feeling. So for example, levels of stress as measured by heart rate, which is a typical example. It's something that is still not very popular nowadays in most cases. Here's simply a quick example from a video game in which the video game adapts itself based on the stress levels of the user who is equipped with a sensor, in this case, a heart rate monitor. So in this case, certain aspects of the game adapt themselves, such as the water here. But there is no system in order to convey the effects of sensory overload that is actually using closed loop interaction. So here is the system that we developed and that I am presenting. First of all, it's a virtual reality system in order to bring, to create a more immersive experience for the users. Importantly, it includes closed loop interaction through biofeedback. So this thing that I was just explaining, and using different sensors, as I will explain later, the interaction is adapted in real time. And well, this is optional, although of course it's quite a core component of the experience, but it can be adapted to be used without it. In this case, the experience takes place in a 3D environment that we developed using Unity. In this case, it's a classroom setting. So we place the user in a table in a classroom, as you can see here in the image, and they have to be attending a lesson, in this case about astronomy. While we provide certain sensory overstimulation on purpose in order to bring out some of the stimuli that for people with ASD would actually cause sensory overload. We will see this in the next slide. And we'll also just to mention that there are certain characters that are animated with body movements and facial expressions. And in the case of the teacher, also the mouth movements are synchronized with the voice recording that we are showing. Here are just some examples of the stimuli that we are providing to the users. In this case, they are of two types, audio or visual. For example, the background noise of peers talking, or a sudden noise, shiny colors, moving patterns. These are things that, in this case, we are trying to exaggerate them in order to create the general feeling of sensory overload, so that participants can actually get a feeling of how this situation will be for someone with ASD. Here we have a video from the very first prototype of the system that we developed. And later I will show you another video. In this case, well, we can see here on the bottom right how the user is interacting, and there are some aspects of
Jupiter's atmosphere is predominantly made up of hydrogen and helium. It has more than 70
some effects. So in this case, the patterns become more visually distracting.
moons.
Here we have some
Asteroids,
visualization of
sometimes
a
called
fact
minor
that the teacher
planets,
was
are
mentioning.
rocky remnants left over from the
We also can hear the noise of peers talking, etc. Just from the very first prototype that we developed. As for the setup of this experience, it is based on the Oculus Rift S headset, which is a virtual reality headset that includes, of course, head tracking. and also the two wireless controllers for interaction, because the user can actually move their hands inside of the system. And in order to bring the biofeedback experience, we use the Empathic AI4, which is a wristband equipped with different sensors for physiology, including an indicator of heart rate as well as electrodermal activity, both of which can correlate with arousal, so a certain level of stress. This is the sensing architecture that was implemented. So basically the technical diagram of how the signals are being processed in real time in order for them to be used by the experience. So here, the Empathic AI4 wristband collects two different kinds of signals, which are electrodermal activity and PPG. Both of the signals are sent using Bluetooth from the wristband to a software, which is called the E4 streaming server. It makes them available using the TCP protocol and using a Python streaming script, and we send it using LSL. LSL stands for Lab Streaming Layer, and it's a protocol commonly used in order to stream physiological signals and make them available in real time. And then MIDAS, which is a software specifically to get these LSL signals and processing them online. So from these measures, we extract arousal, and the virtual experience application can actually get information about these arousal levels in real time in order for it to use this, and then adapt the intensity of the stimuli that are being presented. So if the user is feeling higher levels of arousal, we can increment the intensity of the sensory overload in order to more accurately reproduce the sensory overload that someone with ASD would have. So in this way, we create a more realistic experience that more closely resembles what a person with ASD would experience.
2 minutes left, Hector.
Perfect. So well, briefly showing here how we perform the physiological signal analysis. As I already mentioned, this analog analysis from the PPG, and this gives us information about blood volume pools, which we derive to extract heart rate variability. And then we also have electrodermal activity, and using both of the signals with a moving average algorithm based on a short time window and a long time window. So we divide it, and then we can find out very easily the change in these signals. So this acts as an estimation of arousal. So here I will show you briefly a video of the experience that we created in its first stage. Whoops, sorry. Okay. Oh, I think I stopped sharing my screen by mistake. Okay, sorry for the issues with including video, but well.
The publication as a way of...
So this is kind of the current state of the experience. In this case, we can see a user simply looking around the environment, and well, and some different or sensory stimulations are happening around here, including some noises of the peers talking, or also the dynamic ones, such as when looking at the clock, we can hear the clock ticking faster. So as a conclusion, we have developed here a novel interactive system in VR designed to spread awareness of the experience that some people with ASD live, and that is often overlooked. And this system is enhanced by closed loop interaction using biofeedback to more closely provide this experience in order to further bring awareness of this issue. And actually, this system even can act as a platform for studies related to sensory overload. So the further steps are simply user validation, which could be with neurotypical users or even with neurodiverse users. So this is it for me, and these are the acknowledgements in terms of the rest of authors and the funding, and that's it. Thank you very much. If you have questions, I will gladly answer them.
Did you have any questions? Oh, sorry.
Yes. I just have a small question, a just quick question. Did you perform the experiment on some people. What was the number of people you performed this experiment, just to evaluate what was the impact of this particular virtual reality you created for them?
Mhm. For now, we haven't performed a formal user validation, but we have conducted some pilots with participants, and the number was around 10.
Okay.
And well, they reported actually what we were expecting, that is that they were feeling kind of sensory overloaded, which was kind of the point. But of course, within controlled settings, so nothing creating actually any kind of problem, because we actually verified that the users will be okay with this before starting the experience.
Okay. And will you be able to recommend something for after performing this kind of experiment on larger number of set for their environment conditions?
Yes, we are planning on conducting a few user validation tests. Starting, the first of them would be having the experience, in one case with the sensory overload, in the other case without, and then comparing certain aspects, including the physiological signal, the subjective experience based on questionnaires, and aspects like this. So for this, we are aiming for around 40 participants, and we expect to conduct this around this year, whenever the pandemic situation actually allows us to do it, because of course now it's quite complicated to do this.
Thank you so much.
You're welcome.
Right, yeah, thank you for that, Hector. So up next, we have Quang Vinh Dang, who will be actually presenting 2 presentations. So to begin with, I'll only introduce the first presentation. So the first presentation is going to be reinforcement learning for the problem of detecting intrusion in a computer system. So
yes,
yeah, go ahead.
Yeah, so many thanks, Liam. So I will start to share my screen. Okay, so I suppose that you are looking to my presentation now, right?
Yeah, we can see it.
Okay, so the first topic I present today is reinforcement learning for the problem detecting intrusion in the computer system. I'm repeating the topic. It's an overview, I think 15 minutes, so I will try to go it quickly. Well, it's long text, sorry, but intrusion detection system, if you are working in computer science or you are a computer engineer or software engineer, we all know that, I mean, today we are facing with a lot of attack on the internet, right? And this attack can be called kind of intrusion. And I mean, intrusion detection system, or IDS, I mean, that is a system try to detect the incoming attack before, I mean, it can harm the computer, right? And I mean, if you have experience with, if you have experience with kind of antivirus client application like Kaspersky or McAfee, you all know that, I mean, they need to update the database, I mean, very frequently, because, I mean, in, let's say, in the very beginning of the computer system, like in 1990, 2000 something, I mean, all of the IDS and also antivirus are based on the what we call the signature base. So basically, I mean, there's some guys, I mean, some kind of cybersecurity researchers stay on the lab and they define the signature of, or the pattern of the attack, and they tell the IDS, hey, if you find something like that, stop them because they are kind of attack. And definitely, I mean, it's raised a lot of problem, right? Because, I mean, at least we need to update the database very, very frequently, because, I mean, new attack come in, and I mean, they can somehow bypass the pattern. And I mean, more and more, especially in, let's say, in the last decade, due to the fact that, I mean, machine learning stuff, I mean, achieved a lot of success in, I mean, all kind of thing. I mean, people start to use machine learning quite a lot in the problem intrusion detection. I mean, myself, well, you can see on the screen, myself, I have several papers in recent year, I mean, using the machine learning for the problem intrusion detection system. However, I mean, I would say, usually most of the researchers recently look into the supervised machine learning. Well, I think it's understandable, right? Because, I mean, supervised machine learning is the most, let's say, the most major subfield of machine learning. And in the what does mean when we say the unsupervised, supervised machine learning? Means that we have the very huge data set, right? Usually, I mean, tens or hundreds of gigabytes. And I mean, but the more important point is that we already know what are the attack and what are the benign traffic, right? Means that we have the label. And well, it's cool. In fact, I mean, there's a lot of, I mean, organizations such as the one who's quite famous there is Canadian Institute of Cybersecurity, or CIC for short. They label the data. I mean, a lot of data, but somehow, I mean, in reality, it's not so popular, right? I mean, it's not realistic that, I mean, someone spend, let's say, I don't know, let's say 1 year, 2 years to label manually for the data set. Let's say let's say the supervised machine learning technique achieve a very good predictive performance. I mean, almost 100%. I mean, in all kind of metric you can use in machine learning, accuracy, F1, precision, recall, whatever. I mean, it's very good because it's very powerful, right? But the problem is, I mean, it's based on the assumption that you have kind of label data sets, and probably it doesn't work in practice. So, I mean, in this study, we come up with another brand of machine learning, with reinforcement learning, to to look to the different aspect of the IDS. Yeah. So here is some related work. I would say many I mean, by its nature, the IDS can be considered as a classification problem, right? I mean, there's some kind of traffic coming, and you need to classify either it's good or it's a good guy or bad guy. So it's really very naturally to be considered as the classification problem in machine learning. So I mean, over, let's say, 20 years, I mean, all kind of supervised classification algorithms have been used. Start with something, I would say, region tree in the early 2000s, up to, I would say, kind of gradient booster tree in 2019, 2020, for instance. So I will skip this part. Another problem, I think it's very important, became very important recently. I mean, before 2018, I would say. I mean, no one really cared, because the antivirus, I mean, who care if the antivirus, I mean, misclassify, or I mean, classify correctly or wrongly traffic, right? I mean, we consider, let's say, the antivirus or the firewall as a black box. It run it run what it has been told to run, right? And I mean, that's it. But I mean, more and more, when machine learning plays more important role in our daily life, I mean, people start to ask what happened inside a machine learning box. Such as, I mean, if, I mean, intrusion detection system stop something or allow something, you need to understand why. And after that, you can either debug or or improve the system. Either let's consider as the black box. So I think, I mean, recently the requirement to understand and explain the machine learning problem in intrusion detection, I mean, has attracted, I mean, more attention than before. Okay. In fact, I mean, there's much more related work, but definitely I have to present the most related one. So let's go to the data set. We use the data set CSC IDS 2017. I think it's quite recent. If you, I mean, in this field, we have, I mean, several data sets, and I mean, in the paper, we already discussed the disadvantage of some data sets, such as the very popular one, the NSLKDD 1999, public, and it's as the name suggested, public, I mean, more than 20 years ago. It's very popular, and many research study, I mean, use the data sets to, to evaluate, so I mean, we can compare the approach of each other. But somehow, I mean, the data set released in 20 years ago. And I mean, the internet, the computer, everything, many things have changed a lot since last time. So, I mean, we try to use more recent data set, more modern data set. And the data set is is created by capturing real-world network traffic in 5 days in 2017. At the time of writing this, the data set is quite modern, but I believe CIC also released one more recently, the version of 2020. They just released that, I think, 1 month ago or something. Yeah. So let's talk about the reinforcement learning. Well, I will skip the mathematics here. But anyway, the idea of the reinforcement learning is quite different from supervised learning in terms that in supervised learning we already know what is a good guy and what is a bad guy, right? I mean, we have the historical data when we know that who's a good guy and well, who's a bad guy. And what we try to learn is we try to learn the pattern of good guy and pattern of bad guy. And after that, if the new guy come in and we can compare the new guy with the good guy and bad guy, and we say that you kind of look like a good guy for us, so I mean we let you go. In reinforcement learning, we need somehow to interact with the system. So basically, at the beginning, we have to, I mean, let's say randomly let someone come in and stop someone, right? And after that, we observe the feedback of the system, and we see if, I mean, the guy we let him go is good or bad. And after that, we update the model to, I mean, to adapt better with the new guys come in later on. I will skip the mathematics here. And come to the result, I would say. Unfortunately, well, first of all, I have to say, in the classification, I mean, usually in terms of intrusion detection, we don't use kind of AUC or accuracy because, I mean, they are kind of misleading metric. So, I mean, many research study today use AUC, area under the curve, state the trade-off between the false positive and true positive of the classification. Unfortunately, compared to the how to say, to the math method, we compare to the math approach using supervised learning. I think it's not comparable, but it's better than kind of other works such as FVM. So I think it's understandable, right? Because reinforcement learning is some kind of, we don't have the label data, so we save a lot of effort and money in building the data, and we have to pay the price that the performance, the predictive performance, is a little bit less than the best one. But somehow I think it's kind of interesting approach and interesting work to follow. And in the future, what I want to do, in fact, that I'm doing research now, is I try to simulate the interaction between the simulation and the model without really actually run the model. You see, one major disadvantage of reinforcement learning is you have to let someone come in the beginning, and maybe it's too late to fix anything afterward if you let some very bad guy come in and he destroy everything, right? After that, there's nothing to fix. So the idea is we want to somehow kind of simulating the interaction between the environment and the model, without really run the model and let someone, I mean, destroy the whole system. I think that's conclude my presentation with some reference, my own paper, I would say. And I think that's it for the first presentation. Now I think it's time for question, if any. Thank you.
Right, yeah, thank you. If anyone's got questions before you start the the next presentation.
Yes, just a small question. While using both the algorithm, both kind of algorithm like supervised learning as well as the reinforcement learning, the only thing is, did you consider the time complexity also for the comparison?
Yes. Well, in fact, no. I would say the problem is that the training the model is usually is not a problem, right? You can train the model offline.
Yes.
Let's say you can run that in 1 day or 2 days. But
Okay.
after that, you deploy the model into the practical.
Real.
And I also compare that. But today, I mean, even the IoT device such as Raspberry Pi, it can perform very well. I mean, for instance, it can predict, let's say, 1 million of records in less than 1 second. So it's, at least, I mean, from my very personal point of view, it's not yet the problem, because today, I mean, even you see, I mean, even our smartphone, I mean, has a very powerful computational power.
Okay, thank you.
Yeah.
Yeah, so if you'd like to start the next one, then feel free, unless you have more questions.
Okay, thank you. I will stop sharing and start the next one. Okay. Yes. Okay. So it's me again. Thank you very much. It's me again, and with at this time, I mean, a lot of people follow up. So what is the topic of the presentation is a group influence value in logistic regression model and gradient boosting model. I come from the University of Ho Chi Minh City, but some of the people here are my students, and some are my team member of the company. Okay. Oh, sorry. Okay. So again, it's agenda. So let's talk about the motivation. To be honest, I don't really know, I mean, how dice work in other company, but at least in Vietnam, I mean, my rational company at the moment, the sharing data hub is quite common. Mean that sharing data hub means that, I mean, some company or some organization, right? I mean, they combine their data into one hub, and after that they try to build a model on that, or try to monetize the data. I mean, the most popular example is the banking service or financial company. They try to organize a very big sharing data hub, and after that you can build a credit scoring model on the top of the sharing data hub, right? And after that you monetize the service. However, one very big question that I mean raised up in practice is that how do we determine the value of sharing data? I mean there's several company. I mean, company A contribute 1 million record, right? Company B contribute 500,000 records. But that doesn't mean that, I mean, the value of A is, I mean, kind of double of B. Well, not really, right? It's maybe that, I mean, A provide only kind of rabbit record, while B provide very kind of valuable information. We don't know, right? We cannot, I mean, just simply count the number or count the size or whatever. So we need some kind of mathematical way to determine the value of the contributing data. After that, I mean, we can create the business model for the sharing data hub. So the idea is, in this paper we present kind of a lightweight approach to do the task. Well, I mean, from the machine learning point of view, I think the problem is simple to solve. That's unfortunately it's kind of just like NP problem in algorithm. Like, it's in theory it's easy to solve, but in practice, I mean, it will take a lot of time, probably never finish. So in this paper, our contribution is provide kind of the lightweight approximation that, I mean, we can still calculate the contribution of the data without losing a lot of accuracy. So related, well, unfortunately, as I said, I mean, very recent today, right? I mean, people start to talk about big data, about the data is new oil, about the value of the data, right? And I mean, people start to think about, I mean, if we contribute or if we sharing the data, what is the value of my data? For instance, if Facebook use my data, what is the value of my data, right? So there's not much paper related to the problem. I think it's relatively new. We focus on two papers. First is the influence function of group for parameter model written by code in 2018. And the other is about the influence function of the training data point for only for gradient boosted decision tree model, GDPT, also written in 2018. So in this study, we combine these two approaches, and also we provide kind of our new contribution. Well, so again, it's a lot of mathematics here. Let me try to somehow skip them. But the idea is using the GDBT, mean gradient boosted tree models, such as XGBoost, CastBoost, LiGBM, for instance, on this kind of stuff. What we can do is for Sakilab, propose is we can use the GDPT to calculate the influence or the contribution of each data point to the sharing data hub, and what and also the contribution of code add-on in 2018 is if we try to consider, try to calculate, try to estimate the contribution of big data point, it will take, I mean it will run forever, because let's say today the modern data set contain billions of, even more data point, and if we try to estimate each of them, I mean, we never finish. So the idea of code is somehow we can estimate the influence or the contribution of the subset or the subgroup of the data set. Right? I think it's kind of somehow really revolutionary idea, because I mean it's make the problem be practical. And after that, I mean, through all the mathematics we present here, our contribution is, instead of GDBT that we take again, even with the contribution of code that estimate the influence of a group, with the GDBT is we take, I mean, let's say on our own system and on the cargo data set, cargo credits scoring data set, quite popular one, it will take probably several months to run, to estimate on kind of the influence of own group. So our idea is we replace the very heavy weight, the heavy GDBT by the more lightweight logistic regression model. And we come to the result, I would say. First of all, here is ROC curve for the logistic model for home credit data. If you took a look to the cargo, I think it's more or less state of the art, and I mean the best AUC we can have. Furthermore, here is sorry, something wrong with the display or presentation. Yes, we divide the data into 21 groups, sorry, data holder. We call the data holder, and we assume that the data is contributed by, let's say, 21 companies to the data set. And here for the chart, the y-axis percentage means the contribution of the data group to the final model, and we can see that, let's say, the group 13 have more or less double contribution compared to group 12. So if we somehow need to distribute or share the revenue, the group 13 should have, I mean, twice the money of the group 12, right? And the upper part display the inference score of the ZDPT, the original method of Serif, and the lower part display the inference score calculated by our method. And here is the differences between our method and the Serif method. We see that it's mostly the same, right? The difference is only around 0.1, 0.2%. I mean, doesn't matter a lot, right? However, compared to the time, well, you can see it's in terms of the second. You can see that, I mean, well, I think the chart is, I mean, explain by itself that we can optimize the time by, let's say, 50 or 100 times. And so to conclude our presentation today, in this paper we propose a new lightweight method that provides almost the ideal or almost the same result with the method presented in the paper of Serif and Co. in 2018. But on the other hand, we reduce running time to, let's say 100 times in terms of the running time. So in the future,
sorry to interrupt. We've only got 2 minutes left.
Okay, it's going to the end. So in the paper, in the future, we will work on the dynamic problem when the data points are added and removed frequently. In this paper, we only consider kind of static data set, but in fact, I mean, in practice, it's very common that, I mean, company organization, I mean, flow this new data into this the sharing hub. So that will work in the future, and this also conclude my presentation many times with some reference. Yeah, thank you.
Thanks for that. Has anyone got any questions?
Again, a small question only. The nature of data is also influence the model?
Yeah, very good question. In fact, the nature of the data and the nature of the problem is, well, for instance, if the same data but you solve different problem, you will have a different inference score. And I think it's a good point of this approach because, for instance, if you use the data to build a credit scoring model or you build kind of recommendation system or marketing, it will have a different influence. It means that you have different value in different tasks, right? So it's really dynamic and it reflects the real contribution of your data.
Yes. Then in that case, we can take a multiple case study from same kind of data.
Yeah, exactly. Just like if Facebook use your data to train your facial recognition, or Facebook can use your data to train their advertisement, they will have you. I mean, your data will play kind of different role even if it's in the same data, right?
Yes. Thank you so much.
Yeah, thank you.
All right, thanks for that. Just 1 second. So next up, we have Anthony Abdel Nasir, who will be presenting a machine learning approach on Earth moving fleet selection case study.
Hello.
Project Lebanon. Hi, Anthony.
Hello, can you hear me well?
Yeah, I can hear you.
Okay, great. All right, I am gonna share my screen.
Yeah.
All right, I believe you can see it now, right?
It says it starts screen sharing, but I think it will just take a second to load because it's just the screen's blank and it just says Anthony has started screen sharing.
Wait 1 second.
Can you see anything? Yeah, just give it another try.
Okay, I believe you should be able to see it now, or still not.
It's still just a blank screen. It just says Anthony has started screen sharing. If you try, just click on the, do it again and then just, so go share screen.
Okay, listen, I
click it.
think I'll do it this way. I think I'll do it this way. It should work now, and then now I think it should work fine now, correct?
No, it still just says Anthony has started screen sharing. If you click
Yes, your
screen share-
presentation is visible.
Oh, but it's not on my
Presentation.
screen. Apologies. I don't know why that is. It must just be my. Oh, there you go. There you go. Apologies.
Okay, it works now.
Yeah, it must have been mine playing.
All right, great. Hello, everyone. My name is Anthony Abdelmasih, talking to you from Beirut, Lebanon. I am a part-time PhD student at USG, Université Saint-Joseph. And also I'm at the other part of my time, I'm an expert and consultant in earth moving and transport solution in Lebanon, Middle East, and Africa. All right, so this conference paper is part of a bigger project that we are working on, and I'll be delivering it. The title will be Machine Learning Approach in Earth Moving Fleet Selection. This will be the outline for our meeting, for our presentation. So I'll start with a quick introduction of the construction industry and some of the challenges. Research being done now by my team, the methodology and the real case study on a project I worked on in Lebanon. So obviously, when we talk about construction and mining industry, we are talking about earth moving operation. And by construction, I mean horizontal construction more than vertical construction. And in construction, we talk about the major inputs are construction equipment, labor, and material. My focus primarily will be construction equipment, even though I'll be looking also at labor and material. If we are to look at the construction industry, and if you want to go a bit wider on the mining industry, we can say that it needs to shift towards more sustainable practices. What we can feel now is that the construction industry has somehow a poor performance, and that's due to low digitization, low ICT and IoT integration. Add to it the many uncertainties that you face on the construction site, the difficult nature, the value chain is complicated, it's highly cyclical, competition can be a bit tough, and we know that a lot of projects go out of budget and out of deadline. And not to forget the carbon footprint. So what we see, the shift is more towards more simulation and analytics to support decision making, to make our working environment safer, more informed decision, adapt better to cycles, and to use the maximum we can do from ICT and digitization, which is coming now. So from here, we see a big opportunity to optimize the operations, the earth moving operation. This is just a quick screenshot of the two projects mainly we are working on. So the first one, I'll be presenting a part of it. And the second one in parallel is integration of future technologies, in particular autonomous and electrification in mining. So the methodology used in this paper will be a mix between a simulation model and a machine learning approach. So it will be as follows. In the simulation model, we will be inputting our parameters and the variables as well. Also in the simulation model, we will be calculating our fitness, which will go into the machine learning and will be optimized in order to reach the best fitness or the best solution for our job. This is a quick list of the input parameters we are using. Of course, they are site related. They can help us get the revenue, the cost, any penalties, everything we can input based on the site, whether it's in Lebanon, in South Africa, or in Europe. So it's very much versatile. Of course, we need to enter the machine information. Now, the input parameters that we are to change, and we will talk about it in the genetic part or in the machine learning, will be the number of trucks and the fleet selection. So as you can see in the table below, so we are talking about 3 different truck sizes, and each the number of these truck sizes, and the loading equipment, whether it's a wheel loader or excavator, and the maintenance program. I'll be talking about the maintenance program in a few slides. This is a list of real machines based on Volvo construction equipment, and the values, they are very much accurate. Of course, the ownership cost is a rough number of the, not a rough number, it's an estimate of the initial cost of the equipment depreciated over seven years. The simulation model was done on AnyLogic. It's based on discrete event simulation. I chose discrete event simulation rather than agent-based modeling or system dynamics because I believe it was the best way for me to model the scenario in the best, in most details. And of course, as you can see on the right, this is a run an animation of the run being used using Google Earth actually. All right, and in this case, I use the hauling units as agents, the loading units as resources. This is a pure stochastic model. This is a quick overview of the main costs that we talk about, especially when you are in the field of equipment. So we talk about ownership cost and operating cost. All these parameters will take part of my fitness, which I'll talk about in a few. All right. This is an additional feature that we improvised, and it's the maintenance and repair. So what I'm trying to do here, I'll not go in too much details, but I'm trying to optimize the maintenance program. And by maintenance program, I mean the interval for service. And the interval for service affects and has an impact on the repair cost and repair interval and the downtime of the machine. So from here, I am simulating 4 different scenarios where, for instance, I do the service every 250 or every 500 hours or 1000 or 4000, which in other words, 4000, we are not doing any maintenance. Okay, we will see the result at the end of this presentation. In the simulation model as well, we will be calculating our objective function, in other words, the fitness, and it will be the profit and loss and the total cost of ownership. I did not, for the sake of this presentation, detail much my equation to make it easy and understandable. So we are talking about the revenue, the cost, any emission cost. I'll not talk about the emission cost model that we created now, but it takes part, emission cost has a part, and any penalty cost for delays. Moving forward, I used as a machine learning evolutionary programming, in particular genetic optimization. I know a lot of our colleagues already tested genetic optimization, and also in our field, genetic optimization has been tested a lot. Now I did some tweaks over it, and I will explain what we did and how I used this method. And again, as we can see, the chromosome that we are using in the genetic optimization will be the fleet configuration. All right. What we did actually is that we tested 2 different approaches for genetic optimization. One based on random integer, the second one based on random key for sequencing. In a few words, the random integer is based that every machine type has 1 gene, and the value of this gene will define the number of this particular machine type. On the other hand, the random key for sequencing, every single gene depicts 0 or 1 unit. So our chromosome is much longer, and technically this should allow for more versatility, more originality in creating chromosomes, and the mutation will have a bigger impact on this chromosome rather than in the approach 1. I'm happy to discuss it more if you have time at the end of the presentation. This is the case study that we will be doing. This is a real project that I assisted also, and it was also there was an article about it. It's a landfill not far, actually, every one of you heard of the port and the big blast is very close to the blast, unfortunately. going forward. This is a quick, an overall project improvement, and the result that you can see after running the model. You can see that as we go in the generation, the objective function improves. So here you see on the graph the maximum value from each generation and the average value of each generation. And here, this graph depicts 400 unsupervised iterations. Based on the information I know about the site and what the model optimized, we see there is a big difference, big improvement in the profit and loss function. The model recorded 2.3 million for the actual fleet. The optimized fleet offered a bit less than 5 million. The table on the right gives a more accurate information about the two different fleet configurations and how much fuel we saved and the time to complete the project. So even though the optimized fleet had longer time, but it managed to have much lower cost and much lower number of equipment. And this was also defined in much higher utilization of the equipment. A second part of the research was that we tested between forcing the model to choose between smaller equipment and bigger equipment. Of course, here in the combustion engine type model, the bigger the machine is, the less the unit costs, okay, with bigger machines. It's very important to give a quick insight of a parallel work I'm doing currently. With electrification, this is going the opposite, and there is now, if you want, a sentence going on that we should go from elephants to ants when we go into electrification. So we must go into smaller equipment, all right? So this is just a side note from another research we are doing. This is the comparison between the two different genetic algorithm approaches. As we can see that the red lines, it is the random key approach, and it yielded faster, it reached the best or the near optimal solution faster, and it gave us a higher number of the fitness function compared to the random integer approach. Now you can see on the right side, it was important also to look at the standard deviation of each curve. And this was explained that the random key approach, it didn't have a very consistent curve, but it has a lot of, or again, originality or a big discrepancy in the fleet configurations and in the chromosome shape, if you want to say.
Sorry to interrupt. We've got 2 minutes left.
Yes, I'm almost done.
Yeah.
This is the slide before the last, and this is here we tested the maintenance and repair approach, and what we can say about this finding is that there is a big potential for the maintenance and repair approach when we combine it with connected machines, where we know the repair cost, the failure interval from connected machines. Now, how I did this approach is that I took the records of machines that I know and I input these values in the repair and failure function, which is the uncertainty. Okay, so the maintenance cost is not uncertain. We know the maintenance cost. And we see that when we do not have a repair, when the repair is ignored, the maintenance function converges toward the minimum maintenance because the maintenance does not impact a higher repair. All right. Again, I'm happy to talk about this at the end if there are any questions about this finding. What we can say is that simulation and machine learning is very important prior to the construction project or also during the construction project. It's very important. My model proved that it's very important not to have pre-selected scenarios, as I know a lot of literature review did that. All right, so we allow here the model to mix and match between small and big equipment. Random key for sequencing gave greater versatility in generating chromosomes, and the findings from the maintenance and repair is very promising, especially with connected technologies. Some of the future work I am working on now, again, it's in the future technologies in mining application, and I'm currently working on dynamic optimization problem and shift scheduling and in resource allocation. And that would be the last slide. I know it was a bit condensed, but I tried to cover it in the right time. All right. I'm happy to listen to have any questions, if any.
Yeah, if anyone has any questions, put them in the chat box. But if not, I'll just hand over to the chair, Amita.
Yes, a very small question. Why did you select genetic algorithm only for your optimization?
Listen, it's a good question. Actually, I did a lot of literature review about it, and you know, there are the heuristic and the meta-heuristic approaches, and I actually investigated the neural network heavily, and we felt with my advisor that genetic approach is more suitable for my application, especially that I do not have a lot of data, for example, to run neural network training. So I do not have extensive data. And you know, in the construction industry, it's very uncertain. No project is similar to another, all right? It's not like a factory, you have a fixed chain or a production line. So it was, we tried, but we decided to stick to genetic and develop more on it. And outside the scope of this presentation, we are doing a lot of work on the genetic algorithm and a lot of tweaks here and there, and putting some constraints in how we generate the chromosomes, etc. But yeah, that would be. I would like to mention here on that point, since you asked about it, I know that a lot of manufacturers of construction equipment are using currently neural network to predict the repair and failure of every machine. So they would enter, I know some companies, and I attended a conference not long ago, so they are training neural network in order to predict the repair and failure function.
Yes, but genetic algorithm is optimization function, optimization algorithm. So you try to optimize the prediction model, or you just you have your prediction model, na? You have your prediction algorithm.
What do you mean? I am optimizing my fitness, my objective function, which is the profit and loss and the total cost of ownership.
So you try to predict something with that function?
No, I'm not trying. I am trying to figure out the best solution for every job. Of course, I'm trying to predict the best service interval. I'm trying to predict the fleet that has the lowest carbon footprint. This was outside the scope of this presentation. But the sure thing is that I have my objective function. Of course, it's a stochastic model because there are a lot of uncertainties, and I made sure I include these uncertainties in my AnyLogic simulation platform. So yeah.
Again, did you find the size of the data you're providing to your genetic algorithm, how it affect the results? Does it affect the results?
I simulated over 20 generations. Okay. So in every generation, I also have 20 iterations. So in total, I'm working around 400. I felt that I did not need to increase the 400 iterations, so the size of the data, because I recorded that around the 15th generation, the objective function starts to have a plateau and to converge. So we figure out that it's fine. I don't need to go to have, because as you know, it takes time to run 400 iterations, and my model is pretty much dense. My simulation is pretty much dense. And yeah, so that's what I can say.
Thank you so much.
Sure.
Right, thanks a lot for that. So quickly, before we leave, I'm just going to make a few remarks, and then I'll get everyone to turn their cameras on so we can take a picture for the website. So I'll quickly say a few things. Just to the co-host, are you able to quickly do the put the PowerPoint up, as I haven't got it? Thank you. Right, I'll just quickly start with saying a few words. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of the International Congress. I hope this session was informative and knowledgeable as well. All the presenters will be getting their digital certificates through mail within 2 working days. Further, all the papers have already been forwarded to the Springer. Publication will be live within 4 to 6 months. I'd also like to thank our session chair, Amita Sharma, for chairing the session. We have this certificate here as a token of appreciation to the chair on behalf of the team at ICICT 2021 and Global Knowledge Research Foundation. Thank you for your valuable presence. So just before we go, if I could quickly, bear with me, if I could quickly get everyone to display their cameras, just so I can take a screenshot very quickly, please. It's just going to go on the website. Hector, can we get yours back on? Yeah, nice one. Anyone else? If you haven't got webcam, that's fine. It doesn't look like anyone else will be, so I'm just going to quickly take a screenshot and then that'll be it. Ooh. Right, that's it. Thank you, everyone. Cheers. Bye.
Thank you.